Okay, so here is the first problem we did. So let's do another one. Let's do one more like this, and then you'll see, hopefully, what happens. Now, I'm going to even get more complicated with this one. X squared plus 2x plus 5. Find the first derivative of this using the old-fashioned way, which really stinks. But then we'll start taking a shortcut. Okay? So we need to take the limit as h approaches 0 of f of x plus h minus f of x all over h. So we take x plus h squared plus 2 times x plus h plus 5, because that's f of x plus h. We put x plus h in for each x. How to work with functions. Minus f of x, x squared plus 2x plus 5 all over h. X plus h squared is x plus h times x plus h, which we just did in the last problem, was x squared plus 2xh plus h squared plus, if we distribute the 2 here, 2x plus 2h plus 5, and then distribute the negative through the last part, minus x squared minus 2x minus 5 all over h. Okay, now x squared and x squared cancels. 2x and 2x cancel. Positive 5 and negative 5 cancel. So I'm left with 2xh plus h squared plus 2h. So if we factor an h out, what am I left with? 2x plus h plus 2 all over h. H is cancel, and this is a limit as h approaches 0. So if we stick the 0 in for the h, I get 2x plus 2. That is my derivative. Okay, that's my derivative. Okay, so in the first problem, y was equal to 3x squared, so y prime was equal to 6x. In the second problem, y was equal to x squared plus 2x plus 5, and our first derivative was y equals 2x plus 2. Do you see a pattern of what is happening here? Anybody see a pattern? Exponent times coefficient gets us 6x. Okay, so what happened in this one? Exponent times coefficient. What's my coefficient in front of x? 1, right? So that gives me 2x. Exponent, what's my exponent here? 1 times 2. But then what happened to my 5? Why did it disappear? No, it not just because it just did. X is to the what power? 0 power. Exponent times coefficient. 0 times anything is 0. Exponent times coefficient. This is called the power rule, which is a shortcut.
You didn't tell us.
No, she wasn't allowed to. Sorry. The power rule of finding derivatives. The power rule is this. If y equals mx to the b power, then y prime equals bmx to the b minus 1 power. Okay? You take the exponent times coefficient and so on. So we can really speed up life. So if f of x equals 5x to the fourth minus 3x squared plus 2 minus 2x minus 7, trying to do that the old-fashioned way with the x plus h and all that, the fourth power, that would take forever. And I made people do that in the past just to appreciate the power rule, but not anymore. So what's the first derivative of that? 20x to the third minus 6x plus 2, and the 7 disappears. Not just because it disappears, because it's x to the 0, and 0 times anything is 0. Okay? What if I asked you to find the second derivative of that? Well, the second derivative is just the first derivative of the first derivative. 60x squared minus 6. What if I told you to find the third derivative of that? 120x. What if I told you to find the fourth derivative of that? Not that we'll find fourth derivatives for any reason. 120. What if I told you to find the fifth derivative of that? 0. Okay? All right. The power rule. Now, power rule's super easy on equations like this. Is power rule always super easy?
Yes.
Okay. So, since it's always super easy, Miles, power rule that sucker, Miles. And this is actually easy compared to the radicals that we're going to get to.
Yeah, I have no idea what I'm doing.
Okay. What we're going to do if we have exponents in the denominator is we have to write them in the numerator. So this would be 2x to the negative first power plus 7x to the negative fourth power. Follow the same rules. Rules don't change just because we have negative exponents. So the first derivative of this is 10x. And then plus x to the negative 2. Way to go, Ashlyn. Minus 28x to the negative fifth. So when we do this, we write the final answer back into the original format. So it'd be 10x plus 2 over x squared minus 28 over x to the fifth. Now, sometimes Khan Academy will leave it like that. Okay? Which is fine. I'm fine with that, but yeah. So that's if we have variables in the denominator. Now, the more difficult ones is radicals. Okay, so if we have the first derivative of 7 square root of x minus 8x to the 3/2 power. Let's just do that one once. Now, if you have a radical, you need to change it into fractional exponents to do the power rule. So it's 7x to the 1/2 minus 8x to the 3/2. So, what would be the first derivative of this?
3.5x to the negative.
We write it as 7/2.
Sure.
Okay. Minus 12x to the 1/2. 3/2 minus 1 is 1/2 because 3/2 minus 2/2. So what this really is 7 over 2 square root of x, because x to the negative 1/2 puts x to the 1/2 in the denominator, and then take this, which is x to the square root, or the square root of x, minus 12 square root of x. Now, in the olden days, I used to make people rationalize the denominator. So the final answer would be 7 square root of x over 2x minus 12 square root of x. Or if we wanted a common denominator, we need a 2x here, so we'd multiply this by 2x. So it would be 7 square root of x minus 24x square root of x all over 2x. Any of those answers would be basically correct. But nowadays, for the most part, they've eased up and they accept answers written like that. Okay, when it comes to this.